Namaste, everyone, and a very warm welcome. I'm Dr. Amita Kapoor, and I'm so excited for our journey together today. We're going to unlock a skill that's, well, it's almost like a superpower. We're going to learn the art of prediction. So let's start with a really interesting question, one that kind of connects us back to our own history. You've all heard the stories, right? About the ancient rishis who could predict when the monsoons would arrive, and they were incredibly accurate. But think about it. How did they do that? They didn't have any of the technology we have. No satellites, no fancy computers. So what was their secret? Well, that's what we're going to dig into. You see, this idea of prediction, it's not some new thing from a modern lab. It's actually an ancient science. And the very first predictors, they were our ancestors. They were experts at reading the world around them. You could almost call them the original data scientists. Now, they might not have had supercomputers, but they had something just as powerful, maybe even more so, their incredible power of observation. I mean, just think, by watching the sun and moon day after day, they could figure out the cycles and predict something as amazing as an eclipse. They'd look at the sky, feel the wind, see the clouds forming, and from those tiny clues, they'd know when the monsoon was coming. What they were really doing was finding patterns. And right there, that's the secret sauce. That's the core skill we're going to master today. It all comes down to one thing: finding a pattern and then using that pattern to figure out what might happen next. And guess what? You are about to become a predictor. Okay, so let's jump forward in time, from the ancient world right into a modern science lab. It's time for your first challenge as a predictor. We're going to look at a simple physics puzzle, and it's based on an idea you might already be familiar with, Newton's second law. All right, here's our data. Take a look at this table. It's pretty straightforward. It shows us what happens when we push an object with different amounts of force. And you can see the relationship, right? As the force goes up, so does the acceleration. Now, these numbers, they're not perfectly clean. They're a little bit messy, which is actually great because this is exactly what data looks like when you do an experiment in a real lab. Okay, so a table of numbers is fine. It gives us the facts. But to really see the pattern that's hiding in there, well, for that, we need to turn these numbers into a picture. And this is where things get really interesting. The tool we're going to use is called a scatter plot. It's a really simple but powerful idea. All we do is take each pair of numbers from our table, a force and its matching acceleration, and we put a single dot on a graph to represent it. That's it. So let's plot all our points and see what shape they make. And there we have it. Look at that. Suddenly it's not just a boring table of numbers anymore, is it? It's a picture, and you can see the pattern so clearly now. All the dots are kind of lining up, forming a nearly straight line that goes up and to the right. This is that aha moment we were looking for. Okay, awesome. We can see the pattern. The next step is to describe it using math. We need a simple rule. You could even think of it as a sutra or a formula that sums up what we're seeing. And to do that, we're going to draw something called the line of best fit. So what is a line of best fit? Well, the name pretty much says it all. It's one single straight line that we draw through our dots. Now, it probably won't hit every single dot perfectly, and that's okay. Its job is to show the main trend, to get as close as possible to all the points at once. Think of it like drawing the perfect average path through all our data. And the rule for this line? It's an equation that you've probably seen before in your math class. Y equals mx plus c. All this is, really, is a recipe for drawing a straight line. The m tells us how steep the line is, and the c tells us where it starts. With just those two numbers, we can perfectly describe our pattern. And here's what that looks like. See that single line cutting right through our data points? That one line tells the entire story of what's happening in our experiment. It captures the whole relationship between force and acceleration. This line, this is our model. Okay, this is it. This is the moment we've been working towards. We've taken our data, we've found the pattern, we've even created a mathematical rule for it. So now we get to do what the rishis did. We're going to use our rule to predict something we haven't actually seen or measured. So here's the challenge. If you remember our data table, we never actually tested a force of 5.5 newtons. It's a complete unknown. But we have our model, our line, so we can ask it the question, if we did apply a force of 5.5, what should the acceleration be? And the answer our model gives us is 2.779. Now think about that for a second. We didn't get this number by doing another experiment. We didn't measure anything. We got this number from our mathematical rule. We calculated it. And just like that, we have officially made a prediction. This is exactly what we're talking about. You just took what you already knew, the data we measured, found the pattern, and then used math to figure out something new. That right there is the very heart of scientific prediction. It's incredibly powerful. But, a good scientist always checks their work. So, just how good is our model? Let's take a look. This table compares the actual acceleration we measured with what our model predicted for those same forces. And you can see they're really, really close, but they're not exactly the same. And that teaches us something super important. A model is a fantastic tool, a great approximation of the real world, but it's not a perfect copy. So let's zoom out for a second and think about what we've done. This skill you've just learned, it's so much bigger than just this one physics problem. This is a whole new way of thinking that you can use in all kinds of science and honestly in everyday life too. I mean, seriously, think about it. You can use this exact same idea for so many things. Wondering how the price goes up when you buy more or something? You can model that. Wondering if studying more hours might improve your marks? You can look for a pattern there too. Basically, anytime you see two things that seem to be related in a straight line pattern, you now have the tools to understand what's going on and even predict what will happen next. So, today, you've walked in the footsteps of both ancient rishis and modern scientists. You've learned the secret. Find the pattern, make the rule, and then make the prediction. This power is now in your hands. So, I'll leave you with one final thought. Now that you know how to look for the patterns in the world, what will you predict?